mathematical representation, specifying system properties and also the variables in the system, outlining value flows. So this is how our work looks like. And then there is TCommons. Oops. This is the community around token engineering. I guess you've heard about it. We had a token hatch, so this was the first step in creating this own token economy around token engineering public goods. And this community was created in order to fund and manage the funds for responsible and ethical creation of public goods in token engineering. Yeah, and we're very lucky to now completed our hatch with 1.5 million of donations in the hatch. More than 200 contributors, right? Yeah. 50% of our community. And now going the next step in establishing the actual token economy around it. And all the, I mean, what was most exciting here is building the community and the processes, the decision making, also, and the culture for the token engineering commons. Culture, because why? I mean, launching a token for as a capital asset, fine. But how to? We try to consider, or we're considering tokens as basically a signal in a system, not a currency and not an investment instrument in itself. It's a signal in a system, and there's a huge range of opportunities to steer and monitor economic systems, and therefore we are creating public infrastructure, and public infrastructure needs this responsible and ethical creation of public goods. So we worked, I guess, over 12 months establishing our communities, also all the decision-making process, defining our first economic paradigms and parameters, conflict resolution. So it's not only, particularly TCommons, it's not only about the token and the funding, it's about establishing, yeah, basically a new social institution to run this token engineering discipline, or to further develop this token engineering discipline, which is pretty exciting. Okay, emerging discipline. To put this into context, so you all know 2008 Bitcoin with a first consensus mechanism proof of work, and then Peercoin proof of stake. 2015 Ethereum, the ERC20 token standard, and first white paper smart tokens, the bonding curve with Banco, where, I mean, this is basically, I guess, also the bonding, the base, the fundament of your bonding curve design as well. So this was pretty, for any kind of bootstrapping communities and a token, this was really important. Then 2018 now Filecoin, and the huge wave of ICOs, well, were flooded with money, and 2021 the DeFi space managing 62 billion. I think this is a number from a couple of weeks ago. So what the message is here, this is really significant in terms of what's going on in these ecosystems, of how it impacts their stakeholders' welfare. And then only 2018 there was this first mention of token engineering as a discipline. And we started first meetups in the community 2018 in Berlin, and I think within less than 7 months we had 15 meetup communities in 11 countries. Then 2018 University of Vienna launched the Cryptoeconomics Institute as a first institute in academia on doing research. 2019 Cryptoeconomic Systems Blockchain at first journal and conference series by MIT Media Lab. Still, academia is really lagging behind, I must say, in this area. So there are some institutes like Network Science Claudio Tersoni at University Zurich. I've heard about Turin as well, even though I'm not 100% sure what they are doing. So overall, academia is just picking up, and it's very early stage. And this is also the reason why we say there are so many challenges and standards are set in how crypto economies are designed. So we have to be fast, way faster than academia, create our own academy. 2019 CAD open source. CAD is a framework, it's Python-based to build simulations, models of economic systems, to stress test them and find out if a design holds. And this is basically the first infrastructure for token engineering. So there is not, for computer science, software engineering, there is such a wide variety of tools to develop, to collaborate, also to incentivize, and we don't have that in token engineering, so this is really early stage. And in 2020 we launched the TE Academy. With this, okay, we want to establish this discipline and this approach in, okay, we are building public infrastructure responsibility, plus we can apply a lot of existing domain knowledge from other disciplines. So yeah, let's offer structured education for token engineers. And 2021, as mentioned, had TCommons, this new DAO. We can draw from existing disciplines. So this is from a paper from Michael Sorghum in German Forschungsgear, outlining the multidisciplinary collaboration and also what's relevant for token engineering for this new field. And they call it crypto economic systems, and you can consider token engineering as applied crypto economics. So we have computer science and cryptography, obviously. Then, since these tokens as signals and the entire system is defined by software and we can collect data, we can apply AI and also optimization and control theory to monitor and steer these systems. And this is, of course, so much richer and can be so much more powerful compared to our traditional economic systems. Then industrial and systems engineering, operations research and management science, other disciplines, and of course then economics and game theory, mechanism design, and the social science area with law, philosophy, ethics, political science and governance, since these systems should be, or we have or try to establish decentralized systems. So what about the decision-making processes? What about the iterations and updates that are necessary, then how to govern these systems, and psychology and decision science. So this is the overall picture of these are the disciplines we can draw from, and again, token engineering, applied cryptoeconomics, and we need multidisciplinary collaboration, of course, to develop and make progress. Now, let's take a look of what we did at the TE Academy. So, okay, we wanted to offer structured education in a field that doesn't exist yet. Cool. We started with a first course, and this was Ecosystem Value Flows. Maybe I'll skip to this one. This is a first overview on the token engineering design process as we see it today. And it starts with ecosystem design. Then you have you build a representation of your system, a dynamic model, economic model, a digital twin, run simulations to verify, and only then you implement and have a system in production. And then, of course, with every iteration, enhance functionality, additional incentives, additional stakeholders, you verify in your digital twin. Okay, the first part, ecosystem design, is about your stakeholders. So you define the purpose and the members of your system. And the nice thing or this huge opportunity in cryptoeconomic systems is that we can make it purpose-driven. So we can build incentives to optimize towards a particular goal. And if you think of, okay, we know that we want to, or we need to, for climate change, we need to have CO2 reduction, or we want to have sustainability, or we want to have circular economies. There you always have a particular purpose for this economic system, and you try to come up with mechanisms to optimize, to encourage, and to push your system in a certain direction. And this is new. I mean, today we try to have taxes, for example, to encourage particular behavior, but still enforcement is sometimes hard, and also this granularity of implementing incentives. And this is new, so we can start, or we start with the purpose of the system, we start with the stakeholders in the system, and then break it down to what's their motivation, what can they bring to the table in terms of assets, in terms of what could be their roles. Think of verification in cryptoeconomic systems, or staking. This is also about certain selection mechanisms. These are new roles in economic systems, since we have digital systems, since we have decentralized systems. And so you start with the stakeholders, you start with the system purpose, and then break it down to particular roles, and then value flows. And these value flows are what roles and what activities does these stakeholders take in the system, and what incentives do they get back. And incentives, again, of course, can be monetary, but it can also be access or certain rights, like governance, voting rights. And here, in this ecosystem value flows, we started with this purpose. We adopted a couple of existing tools, like here, business model, or an adapted version of the business model canvas, stakeholder motivation maps and such things, to come up then with a concept with basically stock and flows in the system. So an outline, an architecture of a cryptoeconomic system. And we applied, for example, also co-creation to find out and represent stakeholder behavior and stakeholder motivations in the system design. And as mentioned,
I don't see, when we do a research design, we usually we design a pilot project, or we have a target communities, because we are working on everything we are developing is actually should start and then in a really existing community. And I don't see here like what is the experimentation phase, like
you mean experimentation phase in terms of, for example, you try something with paper vouchers instead of implementing it at once, or
of your model, basically.
Okay, so basically this is all validation until simulation. It's just probably that I don't know to what extent you are building digital models. Do you?
Yeah, I do business modeling as well. I mean, I am economist, I also trained as a computational economist, but the problem is that you always need to test. Modeling is
absolutely
not enough.
Yeah, absolutely. So ecosystem design is about building MVPs, also non-technical MVPs. You are using games, for example, Lego.